are going to start of the Hadoop big data training. As part of the big data, we are starting for the Spark training. So okay. So overview of Spark. Let's learn something about the Spark. And in this course, we are going to learn, before starting the Spark, we are going to learn what is the big data, explanation of big data, MapReduce, and Spark. Local versus distributed system, overview of Hadoop ecosystem, and overview of Spark. So what's the big data? So data that can fit into local computer in the scale of near about to 0 to 32 gigabyte, depending upon your RAM size. Let's say it's 4 GB, 8 GB, and 16 GB. But what we can do if we have a larger set of data, let's say about it's 200 GB, 400 GB, 1 terabytes. So try using the SQL database, moving the onto hard drive instead of the RAM. So if we have lots of data, we are trying to move uh, in search of the storage system, which is called hard drive, not instead of the RAM. Use the distributed system, distributed data in the distributed system in which data are the distributed across the multiple system. So like here we can see the local system. Local system we have only one system. In the distributed system we have one master nodes or master computer, and they have a different kind of the child computer, or which we can call the data nodes or slave nodes or slave machine, what we can call. So in the local was so before a local was a distributed system. In local we have number of fixed number of core, fixed number of CPU, fixed number of RAMs. In the distributed system we have multiple system which consists of core, different core. So big data. A local process will use the computations resource on the single machine. As you know, the local computer, it will use their own RAM and memory. Distributed process has the access to the computational resource across the number of machines connected through the network. All the things are connected to the network. After the certain point, it's easier to scale out many lower CPU machines than try to scale up to single machine via the high CPU machines. So in the distributed system, it's the commodity hardware which can easily brought, and we can connect the new systems. It is required more number of storage, computation. Distributed machine also have advantage. It's easily scaled. You can just add one more machine if you require. They also include fault tolerance. So fault tolerance means if one machine is down, but still we are able to access the data from the other using the machine fails, this whole network can still go on, and we can still use a process our data. Let's discuss typical format distributed architecture in Hadoop. Hadoop is very distributed, very large file across the multiple machine. It's used the Hadoop distributed file system. It's kind of the Unix distribution file system. Hadoop distributed files is nothing but just file system which multiple data nodes are connected through the master nodes. HDFS allow user to work in large data sets. HDFS also duplicates block of data for a fault tolerance. It's also then use the MapReduce for its computation process. For storage purpose, it's used to HDFS. MapReduce allow to computations on the data, and this is the typical architecture of HDFS file system. So traditionally we have master nodes which consist of CPU and RAM, and data nodes which consist of CPU and RAM, data nodes, CPU and RAM, so other nodes. HDFS will use the block size. So a block size means the block of size which process at a time, while the default size for HDFS is 128 megabyte, and which can be changed. And there is a block replication factor, means same data will be duplicate across the three systems. The block this is used for fault tolerance. The block hard distributed way of support the fault tolerance. Smaller block provide a more parallelized during the processing. Multiple copies of block prevent the loss of data due to the failures of any nodes. So now let's discuss about MapReduce. So MapReduce is basically it's a computation system in a typical in a Hadoop environment, Hadoop ecosystem. MapReduce is the way to splitting computation tasks in a distributed set of files such as HDFS. It consists of job tracker. which will be under master nodes, and task tracker on various data nodes. The job tracker send the code to run on the task tracker. The task tracker allocate the CPU and memory for the task and monitor the task on the worker nodes. What we can sort in two distinct parts using HDFS to distribute large data sets. So basically, big data in a Hadoop consists of two things. One is a HDFS part, other is a MapReduce part. HDFS is for storage purpose, MapReduce is for computational task in the distributed data set. Next, we will learn about the latest technology in this space known as Spark. Spark improve the concept of using distributed system. Now, so let's start with this Spark. In these things, we are going to discuss what is a Spark, Spark work versus MapReduce, Spark, what is a Spark RDD, what is a data frames. And so now that in a new environment, Spark come with a data sets. So Spark is one of the latest technology being used in quickly and easily handles in big data. It's open source project of Apache. It was first released in February 2013 and has exploded in popularity due to its ease use of the speed. It was created the AMP lab UC Berkeley. You can think Spark as a flexible alternative of MapReduce. Spark can it's a kind of alternate of MapReduce which is used for computational processing, but MapReduce will take time, but Spark is a file. Spark can read data from typical file system, HDFS, early clouds, Cassandra, AWS S3, and many more things. MapReduce require file to be stored in HDFS. Spark does not require the files to be stored in the HDFS environment. It can be your local system. Spark also perform operating up to its claiming Spark is claiming on the document. It's 100 times faster than the MapReduce. So how does it achieve this speed? So MapReduce write most of data disk after each map and reduce operation. Spark keep most of data in memory after each transformation. So in the typical MapReduce system, we have a lot of map operation, then reduce operation, then the joiner operation. So each time it will write back into Hadoop file system. So during the input-output operation, it will track a lot of operations. So typically, Spark keep most of the data in memory after each transformation. Spark can spill over the disk if the memory is filled. So it can also be store the data in the disk if the memory is full. So now let's go to the Spark RDD. At the core of Spark is the idea. What is RDD? RDD is nothing but resilient distributed data sets. It's a kind of data set. Resilient distributed data sets has a four main feature: distributed collection of data. So it's a distributed collection of data, fault tolerance, and parallel operation, and ability to use many data source. So distributed means collection of data it can take. It can, if any time of failure, it can rebuild, and parallel operation it is do, and ability to use many data source. So this is a Spark RDD. There are driver program which create a Spark context, and a Spark context, and there is a cluster manager here, and a Spark context will send a worker node. Worker is consist of executor. Executor is consist of task and cache. And a Spark RDD, there would be master node, master, and the slave. It's like say typically Hadoop system. RDD are the immutable, means once RDD created, you cannot change the RDD, and its lazy evolution means once you are doing the any kind of results, you are at that time everything will be executed. Otherwise, Spark code will be not calculate everything. There is two type of Spark operation. One is a transformation, and other is action. Transformation are basically follow just one transformation to another transformation. Action is usually perform what a receive what you say to do return to the client machine. This behavior carries over the syntax when the coding. A lot of times you will write the methods call but won't do anything result until you call the action. This makes sense because with large data sets you don't want to calculate the transformation until you are sure the perform of them. right? So we covered a lot of, don't worry if you don't memorize all those details, this will be covered again. We will learn about something actually while doing the coding exercise. Spark, now let's come with a Spark data frame. Spark data frame also known as a standard way to using Spark machine learning capability. Spark data frame documentation is still pretty new and can be sparse. And let's go the brief tour of documentation. Here you can go to the Spark's documentation and where you can find a lot of documentation about machine learning and everything. Thank you.